Hello, so today we're going to be having a look at using sigma notation. So this is something that is in the specification for WJC that you are expected to know how to do. However, today I've not seen any questions specifically using sigma notation, but we're going to go through it just in case. So you should be familiar with quite a few different Greek letters, so you will have come across quite a few at GCSE already. So for example, theta is a Greek letter. You will have come across sigma as a lowercase letter, which is this one. You should know that from your statistics because that was what you used for standard form. Other letters that you use include alpha, you've got beta and gamma. You know, there's quite a few different ones that you've come across already. For this though, we're going to be using the capital letter sigma. I mean, how this is the capital letter version of that, I don't know, but it is. And this letter, if ever you see it, it always refers to the sum. So if we were to take everything, add it together, what is the total and what would we get? So let's try a question. So here is an example. So in this question, you are being asked to find the sum of the first 20 terms, okay, and you're being asked to find the sum of the first 20 terms beginning at the first term, and here you are being given the formula for the arithmetic sequence in this case. So if we were to look at that part there, the arithmetic sequence, the 4r plus 1, substituting in for the different values of r. So if I wanted to know my first term, that would be 4 times 1 plus 1, which is 5. My second term would be 4 times by 2 plus 1, which is 9. My third term, 4 times by 3 plus 1, which is 13. Okay, so you can see that this is producing an arithmetic sequence. So 5, 9, 13, etc., etc. So if I wanted to find the sum of the first 20 terms, I am basically looking to do this, the sum of the first 20 terms. For the formula, okay, so I'll just pop that in. So here you've got your two different formulas for an arithmetic sequence. You can use the first one, which is when you don't know the value of the last term, or if you know the value of the last term, you can use this shortened version. So if we go back up to this, we could actually work out the last term, okay? If we know that there are 20 terms in there, when r is equal to 20, we could work out, so 4 times by 20 plus 1 tells us that our final term is 81. So to get the sum of the first 20 terms here, it would be 20 divided by 2. Our first term, A, if we have a quick look, that was 5, and our last term was 81. So 5 plus 81. So that's equal to 10 times by 86. So the sum of the first 20 terms is going to be 860. So just to recap, the number at the top tells you how many terms. The number at the bottom tells you where you're beginning from. So in this case, we were going right from the start, from the very first term. And the bit in brackets tells you what the formula is for that sequence. And by writing the first few terms out here, and noticing that they were going up by a common difference, that's how I was able to work out that it was an arithmetic sequence. Obviously, if I had to multiply to get from one term to the next, that would be a geometric sequence and I'd use a different formula. So let's have a look at one more example. Okay, so here is our example. You might be able to tell just by looking at the first one that we're going to be working with a geometric sequence, because notice here how we are multiplying to get from one term to the next. Let's go through it. So I'm looking for the total sum of 12 terms, and I want to begin with my first term. So basically I want the sum of all of those first 12 terms. So let's have a look. If I started off by saying that k was equal to 1, I can work out what my first term is. That would be 5 times 3 to the power of 0. That's the same as 5 times by 1, because anything to the power of 0 is 1. My second term is going to be 5 times by 3 to the power of 2 minus 1. That's going to be 5 times by 3, which is 15. Let's have a look at my third term. That would be 5 times by 3 to the power of 2. 3 squared is 9, times by 5 is 45. So I can see here, I'm going from 5 to 15 to 45. I've got a geometric series where my first term is 5, and my common ratio, what I'm multiplying by each time to get from one term to the next, is 3. So if I want to find the sum of the first 12 terms, I'm going to use my formula for a geometric series. So I've got a brackets r to the power of n minus 1 over r minus 1. I am going to use this formula because if you have a look, r isn't between 1 and minus 1, so it's not going to be a converging series. This one is going to be a diverging series. So let's substitute my values in. So I've got 5 times by 3 to the power of 12, take away 1, all over 3 subtract 1. So when you put that into your calculator, you should hopefully come out with 1,328,600. So that's the sum of the first 12 terms. Okay, let's go back now and have a look at part B of the question. So part B of the question, it doesn't look different until you start to dig down. So for this one, I want the first 12 terms, but this time, if you have a look at where I'm beginning from, I am beginning with the 5th term. Now there's something you've got to do here, and it counts for all of them, and I'm going to show you by just writing it out. So imagine I've got those 12 terms. Okay, voila. So if I want to find the sum of my terms between the 5th term and the 12th term, that means that I'm going from here to here. I want to know what the sum is of those terms. Now, there isn't a way that I can use a different formula to work it out. What I'm going to have to do is break it down into 2 separate calculations. So if I want to find out the sum for just this section, I'm first of all going to find out the sum of the total. So starting from when k is equal to 1, so that will give me the value for all of the terms added together. And then if I want to end up with just the total of those inside the red box, what I need to do is subtract the total of the first 4 terms. So this section here is the section that I don't need, so that's the bit that I'm going to subtract to leave me with just those terms. Now, thankfully, I've already got the answer to this. I got that in the first part of the question, so I don't need to do any extra work here at the moment. All I need to do is work out the sum of the first 4 terms. Okay, and again, same formula, a brackets r to the power of n minus 1 all over r minus 1. This time though, remembering that we're going to be using n as the value of 4. So 3 to the power of 4 subtract 1 all over r minus 1. And so for that you should get 200 when you put it into your calculator. So if I want to know the sum of the values between the 5th term, well, including the 5th term, up to and including the 12th term, I've got 1,328,600. Subtract that 200, oh, that's a tricky sum. So 1,328,400. Okay, if you've got any questions, drop me an email. Otherwise, turn to page 77 and have a go at question 1 through to 5. Thanks, guys.